Hello, everybody. I'd like to welcome you to the CMI webinar series designed for and by CMI. And I'm Cynthia Howell, and I'm the Education, Training, and Outreach Manager for CMI. I'd like to tell you a little bit about the webinar. They are hosted by Colorado School of Mines and, of course, broadcast from everywhere, especially these days with COVID. If you have a suggestion for a future webinar, we'd love to hear about it. And you can put that on the exit survey or go to cmi.ameslab.gov and /workforce. This is a public webinar, and recording is going to be available next week on that same website. Again, under the workforce menu. Questions, we are going to hold questions to the end, but I do encourage you to queue them up. All of you know that it takes a while to get questions typed out, and we'd love to have them ready for our presenters as soon as they finish their presentation. I'd like to tell you a little bit about our presenters today. And first, I'd like to introduce to you from Ames Laboratory, Julian Krenrich, and Kenrich, sorry about that, as a leader of the Innovation Partnerships Program at Ames Laboratory. And for CMI, she's responsible for the laboratory's industry outreach and partnership activity, and including sponsored research and contracts. She works collaboratively with Iowa State University Research Foundation, and also she has a BS in chemistry from Creighton University, a PhD in experimental condensed matter physics, and an MBA from Iowa State University. She has experience cultivating research relationships with industry. Obviously, that's what she does so well for CMI, and you're going to hear more about that. Also, we have a second presenter as well, Ms. Ellen Cooper-Smith. She's an expert in decision quality and decision analysis and implementation. She is the president of Decision Frameworks, a decision quality enablement firm providing consulting, training, and software around the globe. One of the things I think is really fun also, she is an alum from Colorado School of Mines. Her first degree was in petroleum engineering. She is a specialized decision analyst, and she's been doing that for the past 25 years. And Julian with Ellen are going to do the presentation today, and I don't want to take any more of their time. So I would love for them to take it over.
Okay, good afternoon. Thank you, Cynthia,
You're
for that
welcome.
introduction. So yeah, Ellen and I'm Julianne Krenrich, and Ellen and I today are here to talk to you a little bit about our project that we've been doing with CMI called Strategic Opportunity Framing for Technology Commercialization. So, you know, straight up, why are we doing this project? Why did we propose this project to the Department of Energy? So a little bit of background, you know, CMI is one of DOE's energy innovation hubs. These hubs bring together DOE national laboratories and universities to do fundamental and applied science that underpin the development of technologies in certain focused areas. And of course, as this audience knows, CMI has a scope to develop alternative technologies that eliminate or reduce reliance on rare earth and other materials that are critical to the success of clean energy technologies. So CMI researchers typically create new technology that are at very low technology readiness levels. That means that a concept has been formulated and proved out at the laboratory scale. So these types of technologies require significant investment and effort, i.e. time and money, from both the research team and partners to de-risk, both from a technology standpoint and to de-risk from a market standpoint before they're ready to be commercialized. So this project was proposed to demonstrate that by bringing the scientists together with individuals who have an understanding of the markets, the economics, or the industry of interest, we can accelerate the transition of the technology to industry. So by intervening early on when researchers are making decisions about technology maturation, we can help them map out a holistic plan for developing and demonstrating the technology, which includes market drivers. So the plan, the ideas, we're including the market drivers here. This understanding also guides the scientists as they transition from a discovery mode to a technology development mode. So how does this support, oh, I should mention, the Ames Laboratory received an award from the DOE's Office of Technology Transitions. I went ahead a little bit too fast. In their program called the Practices to Accelerate the Commercialization of Technology. So we received an award from them to do this project. And how does this support the CMI mission? So part of CMI's mission is to positively impact domestic industry with its technologies. And so I pulled some recent numbers from the CMI website, and you can see that they have a significant number of invention disclosures and patents awarded. And so I worked with the CMI leadership team to select, a few, like 3 to 4 technologies that would have exceptionally disruptive promise. And we wanted to better position these technologies and research teams to find a commercialization partner, because that's going to help increase the likelihood that those are transitioned to industry. So before we go in further about details on the project, Ellen is going to tell you about opportunity framing and what it is.
Cool, thank you. And I'm excited to be here. So next slide. Opportunity framing is really a component of what many know as decision quality, which structures collaborative conversations to solve problems. It has 4 main things that have to occur. So we define the problem, and we're going to be going in and showing you the steps to do that. We frame alternatives. So we never come forward with just one. We have a few alternatives that were carefully considered by the team. We evaluate those alternatives either qualitatively or quantitatively. And then really what we're bringing to the decision maker is an ability to discuss the trade-offs and the impact of each alternative so they can make an informed decision. And what you see here is a collaboration between decision makers and the team. So they don't just talk at the end when they're going to recommend, but they talk at a few key points throughout, especially even at the beginning. Advance. So this process is really designed to counteract biases and make clear, informed decisions. It's a combination of cognitive science and org behavior, along with, when necessary, uncertainty analysis and mathematics. Next slide. All right, it developed really around the 1960s in many universities around the world, but very notably Stanford and Harvard. Organizations that use it are of a variety of backgrounds, all globally. So I think if you advance it, there's a huge sector of decision quality, decision analysis practitioners that include opportunity framing from the oil and energy industry. There's another sector, which I would call from manufacturing. And here you see a variety from tech over to airlines and cars. There's another huge camp around pharmaceuticals and healthcare. And then there are more than Ames Lab in Sandia, but many parts of the government and different government agencies will use aspects of decision quality as well. For those of you who are interested, Julie and I have included 2 really nice videos by champions of decision analysis and decision quality. One, Mr. George Kirkland from Chevron, another, Mr. Matt Fox from ConocoPhillips. And if you are interested in applications like these, there's one free webinar every single month by the Society of Decision Professionals. And so we've provided you those links. All right, opportunity framing workshops, which is really what we're here to discuss, the workshops that CMI has been participating in through Julian's facilitation, really have 3 components to it. So there's, if we advance, there's things we do pre-workshop, and that's really working with the decision makers to provide a problem definition. What problem do they want us to solve? What do they value? What are they going to consider when choosing? What key questions does the evaluation need to answer in order for them to make a decision? And then what's in and out of scope? What decisions have been made that we're not supposed to touch, so that the team understands the solution space? And probably most important is who should be involved. Not only who should be involved in making the decision, But in this next part, Julianne, if you advance it, in the framing workshop, what we really need is those people that have relevant knowledge to participate in what is the situation, what are all the issues we need to consider, what are some viable options, and what risks and uncertainty would they face to operationalize those if those alternatives are chosen. So the last step in the pre-workshop is making sure they have the right people. In the framing workshop, we're going to show more examples of what I just discussed, which is really how do we hit this target the decision makers have set for us. And then post the workshop is going to vary. Some decisions after the workshop is done, they'll meet with their decision makers and they have clarity of action. They can choose just based on the opportunity framing, the qualitative commercial discussions. Post-workshop, things are different. If they can't make a decision, really the discussion is, what will it take? Does it need quantitative analysis? Will we put risk and uncertainty to it so we understand the alternatives and what more is needed to get to a good informed trade-offs discussion so decision makers can decide. The last thing I'd like to say on this slide is what's really important with respect to who's involved when it comes to this opportunity, this technology commercialization and these opportunity framings. We need people from the technology that know it well. We need people from the market who know where it could go. And then we need people that have a sound understanding of the potential economics to move it to commercialization. And so really, Julianne is focused on getting the right people involved. Next. Alrighty, so opportunity framing workflow really utilizes some proven tools that came from these different universities as it's been evolving to facilitate this dialogue. And I'm going to kind of walk through an example of what each of these steps are going through the next slides. But this is our goal, to complete these steps in a technology commercialization opportunity framing session. Alrighty, so we always begin by starting with the decision makers and deciding what is the problem that we're supposed to solve. For our quick example, before we get into the technical details of what CMI has been able to do, is a dinner party example where people are being transferred overseas and a going away party is going to be hosted by Ellen and Fred for that. So this page is really what we would call a problem definition. The first is, why do we need to make a decision at this time, and what is the decision we need to make? Next, it comes into, what do we value? What are the things the decision makers are going to weigh when saying they like alternative A more than alternative B? So we call those values, decision criteria, objectives. The next, which is really important, is what key questions do the decision makers need answered in order to choose, in order to make this decision. And so here we see they're debating things like, should they serve all the favorite foods and have it nice and intimate? Should we have a big blowout? Should we make it just easy on ourselves since the party's coming up very quickly? The last part of problem definition is, where is our solution space? Decisions made which set the scope. So it's going to be on a Friday, it's going to be at my house, we're going to accommodate all dietary needs. This is what we'll see is the problem definition. Next. Alrighty, there's a brainstorming that takes place once we have the problem definition, and that's really where we start in the opportunity framing. There'll be some important grounding presentations from market and commercial and technology, and then there'll be a frame storm, we like to call it. Once all the issues are raised, they'll be categorizing them into facts and decisions and uncertainties. But here you'll see the next step is anything that is a decision is separated into what decisions have been made, we're not going to touch them, and if you advance it, I think, what decisions are our focus. And it's these focus decisions that we work next to come up with different viable alternative solutions to the problem they have set out to solve, which in Julianne's case is commercializing technology. From a dinner party example, we see what they were debating was some around whom to invite, the guest list, and other decisions around what to serve and who's going to prepare it. And so they have built a menu of options, which is called a strategy table, which is a key component and one of our key deliverables from an opportunity framing. So this lets us say, what could we do? And it comes from our issue raising and our focus decisions. Next. We take the focus decisions and the team starts brainstorming different approaches they could take to solve the problem. Each approach would have its own strategy, and they would discuss what is the main objective of the strategy, why would it be viable, that's the rationale, and then they start using that menu of options as a group and defining what that particular approach would entail. Once they do that, they will do that for very different viable alternative approaches that they're debating. And so the next slide shows that we've got one of the strategies for the dinner party is called easy peasy. And you can see they're just going to have close friends and 20 or less, and they're just going to get some food and throw it on the table. And then we're introducing here for each strategy that the team has defined, if you advance, we also work on what's called a decision and risk timeline. And this is quite important because it helps the team operationalize what would be involved, what decisions we'd make, in what chronological order, what we would find out, what decisions we would make. So it puts context and meaning to the strategies, and you're going to hear Julianne comment that it was really those decision risk timelines, once they defined their strategies, that gave them a lot of insights. So this is kind of a product, and here you'll see the other viable alternative was a completely different kind of a dinner party where they're going to have 30 people and they're going to invite lots more, and they're going to have a chef prepare it. It's going to be all their favorite dishes, and they're going to really feel how special they are. And their decision risk timeline is a little more involved to operationalize it. Opportunity framing is going to end with a picture of what we have on the next slide. And that's really a qualitative discussion and assessment of each of the alternative strategies they have framed up as a team. Sometimes this is enough in order for them to make a decision. Other times it is not, but either way, they're going to have a lot of insights and take that to their decision makers to decide, can they make a decision, and if not, how? Before they would look at they're looking at each strategy and comparing it to their value drivers, as you can see. And before they get to this step, they would have done probably either a quick pros and cons for each strategy or a quick SWOT analysis. With that, you guys know everything you need to know about opportunity framing, and we're going to go and look at some of the CMI examples with Julianne. Oh, there you go, qualitative assessment. Okay, Julianne, you take over.
Great. So applying this now to a technology commercialization in CMI. So our first framing workshop focused on, came from focus area 3. The technology was owned by Lawrence Livermore National Laboratory, and it uses engineered microbes to adsorb rare earth elements from dilute aqueous streams. So this technology could provide a new source, maybe even domestic source for rare earth elements, but the research team had struggled to find sustained interest from industry. So they had considered 3 primary feedstocks, coal ash, mine tailings, and electronic waste. And so for this decision problem, as you'll see on the slide, we chose to focus just solely on the e-waste sector. And their decision problem was, what is the best path to value in that electronic waste or e-waste sector? So we assembled a framing team that included other CMI researchers from Idaho National Lab and Oak Ridge National Lab. These people had expertise in e-waste recycling and processing, as well as techno-economic analysis and the market for rare earths. And the CMI Focus Area 3 leadership participated in this, as did the technology transfer point of contact from Lawrence Livermore. And the key questions that we developed here to tackle in this decision problem, they're listed here. As you read through them, I think you'll see that they're heavily focused on market-related issues. So for example, which companies should be targeted to commercialize this technology? What technologies might compete with us? What technologies might we need to complement what we have in order to commercialize? What are the critical uncertainties to de-risk and focus the research to get ready for scale up? So moving on, I will show you, this is the strategy table that we developed after the brainstorming session that Ellen talked about. So we've got kind of 4 primary columns here: de-risking, feedstock source, the product, so the output product, and then potential partners. And the framing team then brainstorms entries, options under each one of these columns. So for example, for e-waste, you might get feedstock from a third-party recycler. We looked at potentially using magnet swarf, so maybe a magnet manufacturer, maybe an electronic producer. So those are the types of things. We looked at a couple of different output products. So those are the types of options. This comes out of the brainstorm from the workshop. So then from this menu, the team brainstormed a total of 6 alternative strategies, and 5 of them fit within sort of a processing business model. So they considered 2 sources of feedstock, low-grade e-scrap or magnet swarf. They considered 2 different products, mixed rare earth oxides or separated rare earth oxides. And then they considered 2 types of separation, either sort of single step, single column, or a 2-step separation process. And out of that, they were able to get 5 alternatives. Then they considered a single alternative that was in a different business model. It was sort of a product business model. And this is in which, in this case, the value is captured by selling the columns themselves to other processors. So this is potentially attractive because the columns could be engineered to capture other non-rare earth elements. So then the team, moving through the process, they went through a qualitative assessment of these 6 strategies. This involved coming up with a decision and risk timeline for each one. And as Ellen said, that really helps to force the team to consider actions they need to take in order and with an estimated timeline to de-risk various technical and market uncertainties for any given strategy. So in a sense, this decision and risk timeline exercise forces the teams to operationalize a strategy. And then once this is complete, the team brainstormed the pros and cons of each strategy. So through the qualitative assessment, the Lawrence Livermore framing team was able to fairly easily rule out 4 of their 6 alternatives. And so of the 6, we were easily able to kind of rule these out. And then after further discussion and refinement, the team actually chose to kind of create a hybrid strategy of the remaining 2. It was sort of, they put them together and kind of put in a decision point. And so that strategy involved the focus on low-grade e-waste scrap as the feedstock, and it would produce the separated rare earth oxide. So from this framing, I think, the workshop provided really the impetus to kind of gather the CMI hive brain, as I called it, to really establish some facts about the e-waste industry and the market for rare earth elements. We were able to identify some brutal truths and key uncertainties, which ultimately really did shape the final strategy. The team ultimately realized that they still had quite a bit of technical development to do, but the framing provided them a clear path of next steps. So one of the key next steps was further TEA. But now they could do more of a refined techno-economic analysis with a better understanding of the basic business model that they would need to use, as well as potential partners that could be approached. And along with that, I think the realization, the key insight that, biosorption really sits in the middle of the value chain. So to commercialize it, there needs to be some pre-processing and post-processing partners to implement that. And I think for the framing team as a whole, some key insights gained from the process was that working collaboratively on this decision problem was really a key to success. And I think there was just a general collective gain and understanding of kind of the situation and the market across the board. Ultimately, that understanding, bringing that market knowledge into the team, it made them realize that ultimately there were a lot fewer alternative strategies that were viable than they had originally anticipated up front when we had first started talking about this. So I thought that was very interesting. So now I want to kind of quickly go through the second framing we did to illustrate how we can adapt the framing to the needs of a specific technology. So our second framing workshop focused on the new permanent magnets that have been developed by scientists at Ames Laboratory and Oak Ridge National Laboratory. This is CMI Focus Area 2. These magnets have the potential to offer industrially relevant performance and largely use industry standard manufacturing methods. But of course, they have an added advantage in that by design, they require substantially fewer critical elements. What was different about this workshop is it's really focused at the level of Focus Area 2. So rather than framing a single technology, we did a frame that would apply to sort of multiple magnet compositions. So we're not looking at a single project, but sort of in general, there are some kind of two major outputs of Focus Area 2, and we're looking at them at kind of that focus area level. So we assembled a team that included the CMI Techno-Economic Analysis team, a consultant with very deep knowledge of the magnet industry, as well as several representatives from US magnet manufacturers. And some of those companies, some of the representatives come from companies that are actually CMI team members or affiliates. And then the CMI Focus Area 2 leadership was really took on the technical leadership for this framing. And then we also had the technology transfer points of contact for both Ames, of the Iowa State University Research Foundation, actually, and Oak Ridge participated. And you can see here, I've listed some of the key questions for this decision problem. And I think as you read through them, you will see again that the focus is really on magnet-related characteristic or market-related characteristics, market-related key questions. What are the key magnet performance characteristics needed to enter a market? What's the number one barrier other than cost? What's an appetite for risk, the appetite to try something new in an industry? And of course, our really top of the line question is, what primary and secondary markets should CMI-developed magnets and processes be employed? Next, as Ellen talked about in that defining the decision problem, this team came up with these value drivers. So this slide shows that, some of the values that drove the qualitative assessment. So, like, do we have domestic manufacturer existence? Are there policy implications here? US supply chains, you may be aware, right? This is a policy issue right now. There's been a lot in the news. Is there an existing US market? What is the value in terms of, are we going for a drop-in replacement versus, potentially requiring a significant redesign in order to get a reduced criticality magnet? Commodity versus premium product, does that application, does that matter? So in the workshop, then we actually, we had a single session to cover the situation analysis, the brainstorming, and that brutal truth formulation. But then at this point, it was pretty clear to us that the market segments for the two magnet families were really going to be quite different. So one family is a cerium cobalt based magnet, and the other one is a substitute for neodymium iron boron. And so we decided to split the rest of the framing basically into separate sessions that each session focused on one magnet family. And so basically this meant that this team kind of got a 2-for-1. So each magnet would have its own strategy table and menu of options and so on. So here I'm showing the snapshot of the strategy table developed for the cerium cobalt magnet family. So we've got application, partners, advocacy, information collection. So again, these columns come out of those decisions that you're debating. And you can see, I've cut this off to fit on the slide, but obviously magnets are used everywhere. So the device type, the potential device type was a very long list. We looked at different potential magnet manufacturers or would-be manufacturers. There's suppliers. potential, we called it advocacy, but potential support in the government for maybe funding or other types of policy support that might help technology commercialization. So for so then out of this table for the cerium cobalt, the team framed up 3 different viable strategies. So one was US DoD adoption. And again, all of these actually are replacing samarium cobalt. So samarium cobalt is the current state-of-the-art magnet, and cerium cobalt can be used as an incumbent replacement. And these were the 3 primary industries that the team felt were really viable. So Department of Defense adoption. This was interesting because with the cerium cobalt magnet that CMI has developed, there's an opportunity, potential opportunity for a North American supply chain. And that could be very interesting to the US Department of Defense. Also, the ability to potentially go into process industries or incumbent replacement. So as Ellen explained earlier, the team did a decision and risk timeline for each of these, and they did a qualitative assessment after that. And sometimes you can make that decision based on a qualitative assessment, and sometimes you can't. In this case, the decision and risk timelines were not really that differentiated. And so the team didn't really have to choose from where they're at today versus say where they need to be in a year and 2 years, regardless of whether you went with potentially a Department of Defense oriented application or process industry or medical industry. You kind of start at the same point, and the process in the next year to 2 was very similar. So there wasn't really a clear driving, there wasn't a real clear driver that you should choose one over the other. I mean, you can see here that the DoD strategy might make sense. There are more greens here, but really all 3 strategies could be pursued. So for the substitute magnet for the neodymium iron boron, which we were just calling our neo magnet, we had a very similar strategy table, as you might expect. But the strategies that the team picked out were very, very different. And that's because the performance characteristics of the neo magnet is really quite a bit different than the cerium cobalt magnet. And so the 2 magnets, are just going to be focused in different areas. So this kind of lists the 5 strategies that the team came up with for the neo magnet. And again, the team performed a qualitative assessment for each of these. So they determined a decision and risk timeline and kind of completed that traffic light assessment. So what we saw was that the decision and risk timelines were not substantially different again, but the timeline underneath the actions did differ. And so it turned out that some of these industries are more heavily regulated or more risk adverse, or going to need more certification. So more time would be needed for kind of some of the same actions. So as a result, the small motors for industrial applications sort of came out on top in terms of do this first, because this industry, this sector, offers the most flexibility in terms of performance needs and characteristics. So it's a good candidate for early adoption. And then the idea here is that the primary goal would be to get the magnet out there in industry, working in a part so that you could truly demonstrate its utility and help build up credibility and performance data, which then you could use to your advantage when you start going into, say, clean energy automotive or the wind and direct drive turbines and wind energy. Clearly, these strategies resonate with CMI and its goals, and there's a path to get there, but you may not be able, doing this as an early adopter might not be the best strategy right off the bat. So some key insights, some key takeaways that the team got, I think, was that, the message was pretty clear. I mean, you really need to develop that state-of-the-art technology to be competitive. And the industry really needs to be able to easily understand the characteristics and sort of understand what you have. So it was helpful to really understand the relevance of data sheets and the idea that once you get those data sheets out to companies, that they're going to want to actually have samples of the materials, of the magnets to test. I think some key insights for the framing team, it was very clear that the industry involvement was really vital in framing these strategies. It was helpful to have a strategy, a timeline, and a plan to kind of plan out that commercialization path, and developing several alternative strategies with clear pathways sort of is going to increase the likelihood of finding a partner, which is going to really increase the likelihood of success. And I think in the case of focus area 2, the timing of this workshop was really good with respect to kind of where the technology is and the fact that they're looking to kind of get through the, over the development hump and start really maturing and trying to work on scaling, in the next year. So before we wrap up, I wanted to kind of talk a little bit about sort of some project, some key benefits that we've seen from the, this project as a whole. So we found that knowledge about the market, the concerns and needs of industry, and how or who to approach were really the largest gaps in our understanding. And I think to be successful, these opportunity framings really must include that knowledge. You must include knowledge about the market and the economics. The situational analysis at the beginning, it's very clear that you've got to get many others beyond the research teams to participate and provide information in order to provide that more holistic and complete picture. And the workshops, I think, have served as that specific bounded activity that made this inclusion more likely to happen. So once we had the decision problem scoped, which we primarily work with the research team, then we could reach out to people with a specific ask about how you could contribute and when. And I think a final key benefit of these strategic opportunity framings is that the research team really gains an understanding of what will be needed to develop and deploy. And, by design, I've been one of them. I was a grad student and a postdoc myself. Researchers, we're trained for discovery. And I think when you get to the research needs that support development and deployment of a technology are a little bit different than discovery mode. And I think these workshops help give researchers a flavor of the difference kind of between those two modes of research. So what's next for this project? Ellen and her team will be offering a training workshop for those that want to learn more about how to do strategic opportunity framing. The workshop will be provided at no cost for CMI team members, DOE personnel, and DOE lab personnel. And so will be virtual. We are targeting holding this workshop in August. And I personally think it will be useful for researchers, for tech transfer professionals, or maybe research leaders. And so I'm going to let Ellen jump in and discuss a little bit more about what this training will look like.
Sure. So I've worked with Julianne. This is a portion of the trainings that we do for lots of different types of decision problems. But basically, we're going to have 3.5 hour workshops. They're very interactive. So we'll learn some theory, and then you'll go and we'll have discussion in large group, and then you go to small group breakout. So you'll have the same small group breakout team and your own instructor for those small group sessions, and you'll have one of those each of the 3 days. So on the first day, you're going to learn about what is decision quality, what is framing at a high level on a personal kind of decision, and then we're going to go quickly into a technology decision that has to be commercialized. You'll frame and use more of the rest of the workflow continuing during session 2, and we hope to get you up to your qualitative assessment and your decision and risk timelines. Session 3 is really how to do a project initiation. And for this, we mean an opportunity framing initiation. How would you start it? How would you get your decision maker input? What's involved in preparing for the workshops as you facilitate these different workshop sessions, how you're cleaning it up, and how you're getting everything ready for your insights and a decision trade-off discussion with decision makers. So it should be a good starter for those that want to then try practice this on an upcoming technology themselves or with some coaching.
So with that, thank you, Ellen. We will sort of wrap up. If you are interested in participating in the workshop, please let me know. You can contact me. I can put my email in the chat. There are still certainly seats available for this workshop, so please let me know. And then just to say, we will be doing one more opportunity, framing for CMI. That it's on a TBD yet technology, but we will be doing that later this year. So with that, I really just want to thank you all for your attention, and we will take any questions you may have.
So I'm waiting for people to queue in their questions here. And in the meantime, I'd really like to thank both of you, Jillian and Ellen, for a great presentation of an opportunity for our CMI group to really think about, how do they take research to commercialization in a very thoughtful way. Opportunity framing, all the steps that you shared with us, really with the examples also of what we've currently done at CMI, really make this a huge possibility. And I think I hope that there are some project leads here on the webinar today, because I can't imagine anybody that would think that this would not add tremendous value to the work that they're doing. And we always talk about it in CMI about taking our research to industry, and thus the reason we have so many industry partners. And there's so many steps in between, and you've brought that to light. I really appreciated, Julian, when you talked about switching from the discovery mode as a researcher to the development and deployment mode. And this thinking and framing tends to do that beautifully. We do have a first question up here from Rod Eggert.
Okay, yeah, thank you, Rod. So the question is, did strategic framing lead to tactical changes in R&D activities within the CMI projects that I described? That's an excellent question. I will say that for the Lawrence Livermore team, I think going into the framing, there was a sense that, this technology is sort of ready to go. And I cannot speak to the exact tactical changes, but I know that Carol and Yongqin and Dan, who were leading that technology, there was a lot of discussion about research that they're going to have to do or would be undertaking as a result of that. I probably can't, I'm not privy to all the details, but I think it did make a difference. In terms of the magnets, I think the team has a pretty clear, there are definitely some tactics that they're going to undertake as a result of these decision and risk timelines. I think it became very clear that they kind of need to finalize the magnet compositions and properties and kind of get that done. And then there are some tactical activities that they'll be doing to prepare data sheets. And we talked about like specific conferences and actions and people that they'll be needing to contact. That R&D is a little bit further along. So that's maybe less on the actual R&D. I hope that helps.
Yeah, and if I can say something, you probably didn't notice it, but in the strategy table for the first project with Lawrence Livermore, you saw that one of the things they were debating was what final tests might they want to do prior to bringing it to a test, to a more pilot type phase. And then in the magnets, you didn't see that. Theirs were more activities around what to do as soon as it's ready to start getting it to market discussion so they could fill out which markets they were going to actually target. But they were tactical, they were just different. One was more around, maybe there is a little bit research that would help us answer a few more questions before we get to industry. And go ahead with the next question or answer, Julian.
Yeah, so Yongqin, hello, thank you for joining us. She asked, what are the ways you recommend to bridge this exercise with the project mapping activities in FA4? That's a very good question. I had met, it seems like so long ago, but back in 2020, before the pandemic, I had met with Emmanuel and sort of talked about this project. That was before we actually did any communication with him. And I know that he's, that I've shared with him some of the, like the decision risk timeline for the strategies, but we haven't really had a lot of discussion or follow up about how he's going to incorporate that. But I have been in contact with him, and I have shared some information back with him, and hopefully that's getting put into the mapping that he's doing, which I think is more on the technology side, but we could certainly probably do more there.
Right.
And then Yoshiko has a question. Does your project scope allow for use of strategic framing to help CMI decide at a higher level what research targets we should pursue? The project scope that OTT is supporting doesn't directly support that, but I think the framing process certainly could. And that's probably something that we could talk about as a leadership team, of whether or how we might do that if there's interest.
Right. So different organizations would frame anything from high-level business strategy to portfolio focus strategy to lots of different things. And certainly it's the same process. You're just starting with what is the decision problem, what do we value, and then what questions do we need to answer? And then everything else flows similarly. So it certainly should.
Stacy Joyner has a question. When's the ideal time to run decision framing on a technology once a patent has been filed, or before? That's a great question, Stacy. I would probably recommend that it be done. I guess it depends on the amount of information you want to share about the technology. I would recommend that a patent be filed. I don't think you have to have a patent awarded, of course, but it would be, I think, it's always good to, have that there so that you can sort of talk more easily about with, potential industry. There might be situations, again, like as Ellen said, where you could be framing questions that aren't really, you're not going to have necessarily like specific, potentially patentable information come into it. But yeah, I think having a patent filed is probably a good stage to be at. I don't know, Ellen, you want to add anything there?
Well, I think you can always decide it with a conversation amongst yourselves and with Julian, really would an early framing help us scope out and direct our industry focus? And would that even help us in getting the patent? I don't know. Other than that, what we saw is having an industry and market feel for what the market's going to want. If that would direct your technology development differently in any manner, I would do an early frame. Maybe it's not as extensive. And then a later frame where you want to understand clearly your path to commercialize it. Does that make sense?
Mm-hmm. Yeah.
All right.
We do have a little bit more time for another question or two. And in between time, Julian and Ellen, any more that you'd like to add about the upcoming opportunity in August? Is that going to be, and where it's going to be highlighted, critical times, where might people look for it?
Julian?
Yeah, I will be we actually do have a one-page flyer, and I will be sending out an email kind of to my network, and we'll also be getting it in the critical times as well. And we're going to be actually Ellen and I will be presenting to a group of technology transfer professionals tomorrow that in a group that's a community of practice that's been brought together by OTT. And of course, you know, we'll have it up on, you know, LinkedIn and again, more information in critical times. And I do have a flyer. We'll be getting it out there.
Yeah, and the only other thing I would mention, and I think this just got into one of the answers to one of the questions, is the decisioner's timeline is really a means for you to start to understand how to operationalize your path and get some insights from it. Once you choose, a decision roadmap or a project map is very appropriate. You just can't do a project map of alternatives, right? So you would get some insight, do what you need, and then that's where the project map can put in what is each discipline doing in order to, for their part, to make that decision risk timeline, quote, happen. All right.
Again, I'd like to thank you both so much for a great presentation. I am sure that CMI is going to be excited to have some of this work conducted across the different focus areas. I want to thank our viewers for attending our webinar and webinar series. Many of you have been on every series we've done this year. I'd like to remind you that this recording is going to be available next week at ameslab.gov/CMI under the workforce menu. Again, if you have a suggestion for a future webinar or topic, please contact us. We want to bring things that are valuable to you. The next webinar is going to be held in August. So we're going to have 1 month off here in July. So we'll see you again in August. And of course, all the details will be in the critical times. Thank you again so much to the presenters and for those of you attending.
Thank you.
Thank you.
All right. Have a great rest of the month and we'll see everybody in August.